So these next three all chain together, 5, 6, and 7 all chain together, uh, and they're pretty simple. But let's run through them anyway. So this one's asking us to write a function called isEven that takes an argument n. It takes an integer as an argument and returns true if it's an even number and false if it's an odd number. What we'll want to do is, like they have it tested down here, is if you pass in 10, it should return true. If you pass in 5, it should return false. Now, it should not print out anything. It should not take any inputs. It should just return whether or not it's true or false. So something's going to happen, and we're either going to return true. And remember that when we are writing Boolean values, they're always capitalized, or we'll return false. So we'll have two cases, one that returns true and one that returns false. So when you don't have to write a main function for this one. All you have to do is write your code inside of this definition that they've already started for us, and then it'll test with these four things down here. So think about it real quick. Think about how you would test to see if a number is even or odd. So don't listen ahead. Pause. Think about it. How can we mathematically determine whether or not a number is even or odd? What is an even number? Okay, so the answer is that an even number is any number divisible by 2, right? Which means that we need to see whether or not a integer that is given to this function is divisible by 2. So to test that, we use our old friend modulo. We use modular arithmetic, or use modulo here to test it out. So if n modulo 2 equals, and remember when you are testing for equality, you have to use the double equal sign. That's the equality operator. The other single equal sign is used as the assignment operator. So anytime you want to test for equality, always use double equal sign. And this will mess you up over and over again, but you just have to get used to it. It'll come second nature eventually. So if n modulo 2 equals 0, right? So if you divide n by 2 and there's no remainder, which means it divides evenly, then that means that your number is equal. So if that case is true, return true. So what do we need to do down here? If your thought was right, else return false. That's right, that's fine, that works. To be honest though, we don't even need the else. It's a wasted line of code. So I'm just going to have mine be if this, return true, and then return false immediately afterwards. So what's going to happen when I run this code, and we'll run it and we'll see that it works just fine. What happens is it takes in the integer and then test, is it divisible by 2? If it is divisible by 2, it returns true. So it doesn't run the rest of the function. Anytime your function hits a return value, the rest of the function does not run. It stops running right there. So if n is divisible by 2, return true. But if it's not, then just return false. So if it runs past this if statement and doesn't return true, then the next line just tells it to return false. That way we don't have to have an else statement. So it's kind of silly, and it's all for pardon the dog. It's kind of silly, and it's all for simply losing a line of code. And we could have it this way and make it be slightly more explicit, but it should be obvious when you read it that this works just fine the exact same way. So down here they have us do the same thing, but test for if n is odd. So in this time we're writing is n odd. And it works exactly the same way, right? If n and then something, if n something, return false. Sorry, return true. And then down below, return false. So exactly the same below, but the only thing that's going to change here is what we put in here. So it's still modulo 2. So if n modulo 2 is not equal to 0. So if n modulo 2 returns something other than 0, so if you divide n by 2 and there is some remainder, then you return true. Else, return false. And it runs perfectly. Okay, so this time they want us to write an is odd that doesn't do the test that we did up here. That is instead a call to is even. So inside of is odd here, so we'll need to get is even first. So let's grab is even and drop it in here. So there's is even. So instead of writing out an entire thing that tests, does this divide by 2, again, we can just simply have it return is even. So we're going to call is even, and we're going to pass in n. Now if we do this, it'll check to see is it even. So what we want to do instead is invert this to get the opposite value. So think about it. Think about how we can do that. If you read the chapter, you should know this answer immediately. If we do the simple keyword of not, it simply reverses whatever is over here. So I'm going to return not is even. I don't think that those parentheses are necessary, but I'll put them in there anyway. Let's test it without the parentheses really quick. Yep, still runs same. So what's going on here is anytime we want to test for an odd value, so for example, we're testing is 10 odd, we pass in 10 to n, and we go down here and it says return. So it's telling this function to return the result of is even using the same number. So we're passing 10 to is even, and is even 10 returns true, and then the not changes that true to a false. So return not is even will return whether something is odd. Return the opposite of is even returns odd.